hate computer printers. They're so stupid and two-dimensional.
Hey there, you watch what you say about printers. We're awesome. You obviously know nothing of 3D printing.
3D printing? What on earth is that, weird printer?
3D printing is a process by which a printer, instead of using ink and paper, uses material to build upon itself. By moving fractions of a millimeter at a time, the printer lays down rows of material, layer by layer, building a 3D object. Car parts, kids' toys, household products, even body parts can be fabricated using 3D printers and needed software.
That's crazy. I still don't quite get it.
Well, watch this then.
The MakerBot Replicator 2 desktop 3D printer uses a renewable bioplastic called PLA. When you tell the MakerBot Replicator 2 to make something, it begins by pulling the PLA filament that's spooled in the back up through this tube and into the extruder. The extruder heats it up and squishes it through a very small hole onto the build plate. It starts by laying the bottom layer of your 3D model. Then the platform moves the object down a teeny bit so the extruder can lay down the second layer. The process continues for the next layer, and the next layer, and the next layer. This process can take some time because each layer can be as fine as 100 microns. When you're done, you'll have a professional quality model that doesn't require any sanding or finishing.
3D printing is one of the most exciting innovations in the past 20 years, and it's going to change the way goods are manufactured across many industries. Forget what you know about printing today. A normal printer squirts ink onto paper, but a 3D printer layers atoms on top of each other to print actual objects. To better understand this process, let's look at the history of the 3D printing industry. 3D printing in your home may be closer than you think. It's been happening for about 30 years when Charles Hull invented the process of creating solid three-dimensional objects on a computer in 1984. This technology was mainly used by engineers in the early 90s, but by 1999, medical labs were printing organs using 3D printers with the patient's own cells. In 2002, a great evolution happened when Wake Forest Institute printed a kidney. The 3D scanners were used to create a 3D image of the patient's kidney by using a tissue sample that was smaller than a postage stamp, and then used the computerized process to create the new kidney by printing layers of the tissue. This was a huge breakthrough because more than 90% of those waiting for transplants are specifically waiting for kidneys, and the supply of organs does not meet the need. There's a major health crisis today in terms of the shortage of organs, and we are living longer and therefore our organs aren't lasting. In 2008, the first person to walk on a 3D printed prosthetic leg occurred, and now in 2014, 3D printing has revolutionized the field of prosthetics. By scanning an amputee's surviving limb, medical professionals are able to make a matching prosthetic copy, thereby recreating the body's natural symmetry, which will give the amputee a prosthetic leg that is fabricated specifically for him or her. This ability has made a tremendous improvement in the lives of cancer victims or on military men and women who have lost legs. In 2009, MakerBot Industries, an open source hardware company for 3D printers that was mentioned earlier, started selling DIY kits that allow buyers to make their own 3D printers and products. In 2011, engineers at the University of Southampton designed and flew the world's first 3D printed aircraft. This aircraft was unmanned and it was built in 7 days. 3D printing allowed the plane to be built with elliptical wings that help improve aerodynamic efficiency and minimize the drag. The world's first 3D printed car body was produced in 2011 by Core Ecologic. The car gets 200 miles per gallon on the highway and is estimated to retail for $10,000 to $50,000 if it becomes commercially available. And finally, in 2012, doctors and engineers in the Netherlands used a 3D printer to print a customized 3D prosthetic lower jaw, which was actually implanted to a woman. The future of 3D printing is very exciting, and bioprinting is now in the clinical phase. The great benefit is that the parts are made from the organ recipient's own genetic matter and precisely match the tissue or organ they are to replace. This technology also allows for mass production, which will bring down the cost. Simpler organs such as skin will probably be the first organ to reach the public, and the U.S. military is sponsoring the skin research and hopes to help the military.
Yet, along with this innovation, 3D printing is facing legal challenges. Established players in manufacturing are going after user-generated 3D file sharing sites, arguing that their intellectual property is ripped off by home printers. Gardner believes that as the ability to circumvent licensing and IP fees expand along with the 3D printing market, the cost to companies will reach a staggering $100 billion or more in just 4 years. Can you imagine the impact on a licensing giant like Disney, which generates about 80% of the entire retail industry's licensing revenues? Our copyright laws are unclear about the degree to which 3D designs and software are protectable and what constitutes infringement. Looking ahead, it is important for the courts and Congress to allow in-home manufacturing to blossom and make its full potential contribution to our economy, while controlling the black market for knockoffs and counterfeits. Imagine a world where most products are made locally and aspiring jewelers, cooks, inventors, and designers can create, experiment, and create new markets with a simple investment from their home.